Hey everybody, let's talk stoichiometry. The funny word, but a nice little integration of what we know about moles and what we know about balancing equations. So let's get started. All right, so stoichiometry is the calculation of quantities in chemistry. What that means is that we're basically looking at the bookkeeping of chemistry. We're like auditors, and we're making sure that what goes in is possible to come out. All right, the word stoichiometry is actually Greek in origination. Okay, stoichion is the word element, and metron means to measure. So it means to measure the elements. So it's basically finding the proportion in our reactants and our products. Are they going to match up? Do we obey the law of conservation of mass? Okay, we know that what is going to see in our equations, nothing is created, nothing is destroyed, so we have to make sure that everything works out. Okay, so what is the basic idea behind stoichiometry? What it means is that when we spent time in chapter 8 looking at our balancing, okay, we were balancing out our atoms. Okay, so over here we end up having the equation of N2 and 3 H2s making 2 NH3s. Technically, there is an invisible 1 implied out in front. And what this meant was that one molecule of nitrogen and 3 molecules of hydrogen is going to produce 2 molecules of NH3, which is our ammonia. Well, since we know 6.02 times 10 to the 23rd molecules is equal to 1 mole, we can also say that if we take 1 mole of nitrogen, we get 3 moles of hydrogen to produce 2 moles of NH3. Don't forget, MO stands for molecule, which is the teeny tiny little particle that we see. Okay, that covalently bonded nonmetal compound. And MOL is MOLE, which is the amount. So think of that as like a dozen. So it's really important to remember that every balanced equation is going to show the mole relationship. Okay, so all equations are mole relationships. And they're going to show the proportions between everything. So everything will be proportional to one another. Okay, so if we start with stoichiometry by looking at what we do in a recipe or in the kitchen, we can usually get a good feel of how this is going to work out. All right, so first off, okay, this is my recipe for grilled cheese sandwiches. You take 2 slices of bread and 3 slices of cheese. I like it cheesy. You are going to heat it up, and there you get your recipe for 1 grilled cheese. So, if we were to ask, how many slices of cheese do you need if you have 6 slices of bread? We can look at this 2 to 3 proportion in order to figure it out. Now, a lot of students are really resistant to try this with dimensional analysis, but it's really important that you know how to do it with these easy um, units as opposed to jumping right into moles and molecules and getting confused. So what we would like to do is first identify what is given in the equation, what's unknown, and what our conversion factor is going to be. Factor. Okay, so we are given this number right here, 6 slices of bread, and we want to know how many slices of cheese. So since we're talking bread and cheese, that means we need to look at the bread and cheese in the balanced equation. So we have 2 slices of bread proportionally for every 3 slices of cheese. 2 slices bread. Proportional, not equal, so these are little ratio signs for every 3 slices of cheese. And then we use this proportion in order to solve our equation. So when we solve this, you always start with what is given. All right, so they give you where to start. So I'm going to do 6 slices of bread. And since I have one conversion factor here, I need to put the 2 and the 3 in the correct place. So what we do is we go back to what we were talking about with dimensional analysis. If you are given this unit, bread, and you want to cancel it out, you need to put bread on the bottom so that it does cancel out. 2 slices of bread for every 3 slices of cheese. All right, and you are going to see that bread and bread cancel out, leaving slices of cheese there. Okay, so what do I put in the calculator? In the calculator, you put 6 times 3, and then you divide by 2. If it's in the denominator, you divide it. So what do we get? 6 times 3 is 18. 18 divided by 2 is 9 slices of cheese. Okay? So one famous thing that students always say, Miss Levin, you don't have to do all that. All you have to do is just say, okay, I have 6 slices of bread. I use 2 slices, so 6 divided by 2 gives me 3, and then I need 3 slices of cheese for every one of those, and voila, you get the same number. Guess what? Your brain is doing stoichiometry. Okay? It's very easy to do stoichiometry in your head with cheese and bread and lemonade and marshmallows and whatever kinds of cheeseburgers that recipe that you have, but it gets a little bit tougher when it comes to molecules and moles and formula units and things like that. All right, so you'll see if you have my notes that here we have it all set up with our 6 slices, our 3, and our 2. Please make sure that you use your units and you label your units. The units that you were given need to cancel out in the next step with the units on the bottom so that you end up getting the units that you want, slices of cheese on top. You don't want to get the proportions wrong. Okay, so please try the Fun Side of Stoichiometry worksheet and make sure that you know how to do it with cooking before we do anything with moles. All right, welcome to chemistry and welcome to stoichiometry.